Hello, and this is Sunny. Welcome back. Different types of networking cables are used to connect different devices. In networking, the most common cables include coaxial cable, twisted pair, optical fiber, and parallel or serial cables. Their usage depends on the networking topology, hardware, software, and network size. Networking cables, connectors, and their specifications belong to the physical layer or layer 1 of the OSI model. Today my topic is twisted pair cable, specifically shielded twisted pair, unshielded twisted pair, solid cable versus stranded cable, and a brief introduction to different category rated cables. Most modern network cables are made from 8 wires that are twisted in pairs. Wires are twisted to help eliminate crosstalk, thus improving data transmission performance. Twisted pairs are 4 color-coded insulated copper wire pairs: orange, blue, green, and brown. In each pair, one wire is a solid color, and the other is predominantly white with a color stripe. More wire pair twists per foot means more resistance to crosstalk, higher quality, and more expensive. Twists per meter or foot is called twist ratio. The higher twist ratio, the less crosstalk, but the greater attenuation. It is important to keep a balance between the minimizing crosstalk and reducing attenuation. Twisted pair cables can be shielded or unshielded. Let's look at the structure of shielded twisted pair first. The outer layer is plastic jacket or shield. The second layer is braided shielding, some metallic substance which protects the cable from electromagnetic interference or EMI. Underneath the braided shielding is aluminum foil shielding. In this example, foil shielding wraps an individual set of wires. Some STP cables may have foil shielding for all wires overall, while some STP cables have no foil shielding. STP with the foil shielding, individual or overall, is called FTP, fully shielded twisted pair. Individual shielding help prevent EMI and also crosstalk from neighboring wires. Each copper conduct wire is also covered by plastic insulator. STP cable is often recommended where EMI is strong. In the structured cabling, STP cables are normally used for horizontal cabling. Compared with STP, unshielded twisted pair or UTP has fewer layers of shielding. It has 2 layers, plastic shield and wire insulator, and UTP does not contain additional shielding. As a result, UTP is less resistant to EMI and crosstalk. UTP is the most popular and generally the best option for short and medium-length connections in a network. It is good for making patch cables. Now let's summarize the differences between UTP and STP. STP and UTP in the same level of category can transmit at the same rate. The throughput depends on other factors such as cable category, cable quality, and proper installation. In terms of cost, STP and UTP vary, but generally speaking, STP is more expensive. Both STP and UTP use RG45 connectors. STP is more resistant to noise and EMI. In terms of size scalability, maximum segment length for both types on Ethernet network is 100 meters. Now let's see the differences between the solid core twisted pair and the stranded core twisted pair. The physical differences are straightforward. One stranded wire is made of a bundle of tiny and thin wire strands, while a solid wire consists of one solid and much thicker metal conductor. Stranded cable is not as good a conductor, but is more flexible and stands up to handling without breaking. It's good for patch cables. Solid core twisted pair cable is better conductor, but will break if mishandled. TIA-EIA specifies that horizontal cabling should always be solid core twisted pair. Different maximum bandwidth separates a twisted pair cable into different categories or classes, which are stipulated by two main standards: International ISO standard and American TIA-EIA standard. ISO uses class such as Class A, Class B, Class C, and so on. TIA-EIA standard uses category. Here I briefly introduce several category-rated twisted pair. Cat 3 cable is mainly for the telephone system. It is terminated with RG11 connectors. Cat 5e. Many modern networks use Cat 5e. Cat 5e is enhanced version of Cat 5. Cat 5e cable offers maximum bandwidth 100 MHz and can support gigabit Ethernet. It is now the minimum recognized cable for data networking. Cat 6. They are capable of transmitting at a higher frequency of 250 MHz and up to 10 gigabits per second of transmission rate. Cat 6e further reduces attenuation and crosstalk, and they can reliably transmit data at up to 10 gigabits per second. Many people believe that they need Cat 6 cable run in their homes to support their high-speed internet. It is not true. As a matter of fact, even Cat 5e is technically overkill for today's high-speed internet. A typical high-speed internet service to the home is anywhere from 20 megabits per second to 50 megabits per second. Cat 5e cable can support a gigabit Ethernet, so for the home, don't waste money on Cat 6 cable. I hope everyone stays healthy and safe. Thank you very much. See you next time. Hello, and this is Sunny. Welcome back. Different types of networking cables are used to connect different devices. In networking, the most common cables include coaxial cable, twisted pair, optical fiber, and parallel or serial cables. Their uses depends on the networking topology, hardware, software, and network size. Networking cables, connectors, and their specifications belong to the physical layer or layer 1 of the OSI model. Today my topic is coaxial cable and some common connectors. First, let's look at the structure of the coaxial cable. The outer cover is PVC or fire resistance plastic called sheath. The braided metal shielding reduces electromagnetic interference or EMI. Underneath the shielding is the PVC or Teflon insulator. The central metal core is the copper conductor. Coaxial cable is used to carry high-frequency electrical signals with low losses. It is commonly used in the telephone system, broadband internet, high-speed computer data buses, cable TV, and Ethernet. There are hundreds of specifications, but most types of coax cable use RG number. RG stands for radio guide. Each type serves different purposes. RG6 coax cable, for example, is typical at home if you have cable TV or cable internet. Coax cables are also rated in ohm for their impedance or resistance. An ohm is a unit of resistance to the flow of electrical current through a circuit. Over time, the industry has settled on 50 ohm and 75 ohm for the vast majority of applications. Coax cable looks similar to each other. It is not easy to tell their difference by their physical appearance or size. The best method is to read the product label or simply text on the cable. There are many types of connectors. Here I list 4 common connectors. BNC connectors. BNC stands for British Naval Connector or Bayonet Nail Concealment. Nail concealment refers to 2 persons who invented this type of connectors, but don't worry about what BNC stands for. It is good enough if you recognize them next time you see them. The N connectors, also called Type N connectors. They are weatherproof RF connectors. They are capable of carrying microwave frequency signals. SMA connectors. SMA stands for Subminiature Version A. SMA connectors are often used in high frequency microwave and Wi-Fi systems. F-type connectors are normally used to connect to the cable modem if you have a cable TV or cable internet. RG6 cable is normally terminated with F-type connectors. Compared with twist pair cables, which I will cover in my next video, coax cables carry signals much further and are better shielded from crosstalk. Twist pair cables provide a much higher transmission rate than coax cables in general. For example, Cat6e or Cat7 twist pair cables can carry up to 10 gigabits per second. Coaxial cables are highly resistant to signal interference, but they are more expensive and harder to install. Twist pair cables are flexible and thus more commonly used on the Ethernet networks and telephone systems. I hope this video is helpful. Thank you very much and see you next time. Hello, and this is Sunny. Welcome back. Today my topic is fiber optic cable. Specifically, I will talk about the structure of fiber cable, single-mode fiber, multi-mode fiber, and their major differences. What is fiber optic? Fiber optic cable or optic fiber cable or simply fiber cable is a type of cable that contains one or more optical fibers that are used to carry light. Fiber optic cables offer significantly higher throughput than copper-based cables such as coaxial cable or twist pair cable. Optical fiber may be single-mode or multi-mode. Let's look at the structure of fiber optic cable. Fiber cable consists of center glass core surrounded by several layers of protective materials. The outer layer is a jacket. The insulating jacket is made of Teflon or PVC. The second layer is buffer. which is used to encapsulate one or more optical fibers and provide protection from physical damage. The layer around the fiber core is cladding. Cladding is made of glass or plastic. The cladding layer serves two purposes. 1. It protects the core. 2. The cladding reflects the signal down the fiber. In other words, light travels through the core by constantly bouncing from the cladding. Because the cladding does not absorb any light like a mirror, the light can travel great distances. Besides, the light bouncing or reflection from the cladding allows fiber to bend around corners without affecting the transmission signal. The center core of fiber cable is made of glass fiber. Light or LED travels through the core. Single-mode optical fiber is designed to carry light with a single mode, which means light wave travels in the same way or in the same pattern, and that gives us a single ray of light. Here are some features of single-mode fiber. Single-mode fiber can offer high transfer rates over long distances. The core diameter is very tiny, it's about 9 microns or micrometers. The width of the single human hair ranges from about 20 to 200 microns or micrometers. Without special equipment, we cannot see the core with the naked eye. Laser-generated light travels over one path, and the light does not disperse as the signal travels. Since single-mode fiber can carry signals many miles before repeating, that's why it's better for long distance, such as WAN connection. Internet backbone uses single-mode fiber. If you see a patch cable with a yellow color, it is single-mode fiber. Multimode optic fiber is mostly used for communication over short distances like within a building or on a campus. Light waves are dispersed into numerous paths or modes as they travel through the cable core. Multimode links can be used for data rates up to 100 gigabits per second. Here are some additional features of multimode fiber. Multimode fiber core has a larger diameter than single-mode fiber. Laser or LED generated light travel at different angles, thus it has greater attenuation than single-mode fiber. Module distortion is the sole problem of multimode fiber. Multimode is better for short distance, as I mentioned before. If you see fiber patch cable with orange color, you know it is made from multimode fiber. Let's look at optical fiber core diameter, single-mode fiber versus multimode fiber. Fiber core size is so tiny that we cannot see it without special equipment. We use micrometer or micron as a unit. 1 micrometer is 0.000001 meter, or 1 millionth of a meter. Single-mode core diameter is about 9 micrometer, and multimode fiber core diameter is from 50 micrometers to 62.5 micrometers. The length or size of a typical bacteria is about 1 to 10 micrometers. The diameter of a human hair ranges from 20 to 200 micrometers. The size of COVID-19 virus is approximately 0.1 to 5 micrometer. These viruses are so tiny, yet they are terribly powerful. Be safe. Wash your hands religiously with warm water and soap, at least for 20 seconds. While I wash my hands, I sing happy birthday to you. Happy birthday to you, happy birthday to you, happy birthday dear Sunny, happy birthday to you, at least twice. Let me summarize the major differences between the multi-mode and single mode. Single mode fiber has a smaller core. Laser light travels in a single mode, and single mode fiber is good for long distance. Multi-mode fiber uses several different modes when light travels inside the core. Light or LED travels in different patterns or modes. That's why it's called multi-mode. It has module distortion problem. Multi-mode fiber is good for short distance. It's cheaper than single mode. Now let's compare the fiber cable with the twist pair cable. There are many benefits over copper-based twist pair cable. They can provide extremely high throughput, like 10 gigabits per second, highly noise resistant, excellent security, and they are able to carry signals for longer distances. Of course, there are some drawbacks. Fiber is more expensive than the twist pair cable. Cabling itself is more expensive. Transmitters, fiber equipment are more expensive, and fiber cable installers are more expensive. Fiber cable also requires special equipment and skills. When we choose the cables for our network, we should consider many factors, such as network size, throughput, demand, environment, and budget. No matter which one we choose, choosing the one that best suits our network demands is an important task for every network expert. I hope this video is useful. Thank you very much. See you next time.
Hey guys, this is Dow2Fast here, and this is a video that I've wanted to do for a while. What I'm going to show you in this video is how to put together a Cat5 cable, both a straight through and also a crossover cable, Cat5 cable, Ethernet cable. What I have in front of me is the pinout for both the straight through and the crossover that you need to know to make those cables. Let's first talk about the pinout on the Cat5. So you see there are actually two sections mentioned here. And let me kind of put this in a frame here so you can see it. Top part is the EIA 568A and the bottom part is the EIA 568B. And you'll notice that the color between these two differ slightly. So what you need to know is that if you're making a straight through Cat5 cable, what you want is at both ends of that cable to have this same pinout. Okay, so if you have same pinout on both ends of that one cable, then it's a straight through. If you want to make a crossover cable, what you'll need is that one end need to be this wiring pinout. On the other end, you need to have this one. Okay, so they differ. And let's go through this. Basically, you have starting with pin 1, pin 1 to 8. Okay. So starting with pin 1, you have white, green, green, white, orange, blue, white, blue, orange, white, brown, and brown. And on the crossover side is white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So these are the pinouts that you need to know. You can Google it for like Ethernet pinouts on the internet, and you can find these readily available. Okay, there's one little trick that you should know about these two pinouts. You actually only have to remember one of them. And why I say that is because usually I remember just this top one. Because the difference between this top one and the bottom one is actually all you have to do is flip the orange and the green. What I mean is this. See how it starts with white, green, green? If you look at this one, it's white, orange, orange. And you just flip it. Basically, to make this connector to the bottom, instead of using the orange in the beginning, you start with the green. And anything that's green here, up here, is actually orange. You flip the two colors. That's all you gotta do. So memorize one, and just remember that to make the other end for crossover, just flip the orange and green color. Now, let me show you the Cat5 connector that you need. These are what they call RJ45 connectors. And on the top, there's a tab. There's a locking tab. So when you plug it into a device, it'll lock it in place. This end here is where you feed the cable. And if you look down on this side here, that's where you see the metal pins. Okay. And to know which one is pin 1 to 8, what you want to do is, if you have it this way, flip this over. Okay, so the cable is coming in on the left side, and the metal pins on the right side, starting from the top, is pin 1, 2, 3, 4, 5, 6, 7, 8. That's how you count the pins on the RJ45 connector. Now, a couple of things that you'll need to make a Cat5 cable is you'll need a wire stripper and also a crimper. These are very inexpensive. You can buy these at most home hardware stores. I think Radio Shack still sells these online. If you have like Fry's Electronics nearby, you can get it from them. Now this tool is basically a cutter to strip the insulator. There's a blade inside here with different gauges of wire. Let's first grab a cable, and what I have here is I have a red Cat5 cable that one end already has a connector. Okay, and if you look at it, the tab is broken, so I'm going to have to cut this off and get rid of it. It's rather short cable, but I'm going to just show it to you as an example. Okay. So what you want to do, first thing, is get the cutter and just give it about, say, an inch and a half. Okay. You don't want to make it too short. I just put it around this size here on the cutter, and just a couple of turns, and it comes out. Now you don't want to keep on twisting it because it start cutting into the inside wires. Alright, and we can go ahead and prep this one also. So just do this, quick turn. Okay, so the first thing I would do is I would take each pair, and what you'll find is that they're twisted. These are unshielded twisted pair, as they call it. And I would go ahead and untwist these wires. Alright. So these are nicely untwisted. Okay, let me put it against this background so you can see it. Alright, let's start with this one side. On this cable, I'm going to go ahead and do one end is going to be your 568A pinout, and on the other end I'm going to do the 568B pinout. So this will become a crossover cable. Alright, now starting with the top here, you see that it says green, white. So, and I'll move it up top, so this is green, white. Okay, might be a little hard to see the stripe, but green, white, and I'll hold it in place with my fingers here. followed by orange white, and I'll grab the orange white and I'll line it up. Again, I'm just using my 2 fingers here to hold it in place. Followed by a followed by a blue and a white blue. And what I'm going to do is I'm going to take both of them and place it like this. Again, I'm just keeping it all in place. It's all flat against my finger here. Alright? Followed by the orange. Followed by the white, brown. And then brown. Actually, let me flip this over. I don't like it all twisted. Alright. So, let me carefully rotate this while still holding on so it's still in the same order. I'm not messing up the order, okay? With this type of crimper, there's a cutter here. Alright, so what you want to do is basically feed this in here. Again, don't lose sight of the layout of the wires. Alright? And give it about, say, that's about half an inch or so. Okay. And then you want to cut this off. Again, always hold down the wire so you don't lose it. Alright. Now, again, I flipped this connector earlier. Look at it this way, where pin 1's on top. So I'm going to turn this over this way, where pin 1 is at the bottom now. And this is where you feed the wire. I'm going to carefully put this in here, slowly. And once you get it in there, you'll be able to slide the wire in there until the insulated jacket is in this part of the connector. Okay. The next thing you want to do is look on the side, make sure the wire is fed all the way to the end. If it's not all the way to the end, let's say you cut it too short, it's back over here, you need to start all over. Okay, so these wires are all fed in there. Okay, push it in, make sure everything's all seated properly, and then look for the 8-pin crimper here. Put this in here. Okay, and now just give it a squeeze. Nice tight squeeze here. And this side is done. So this is the 568A pin out that I just did on this end. And let me quickly do the other one where I'm going to put the crossover end. Alright, so I'm not going to go over all the procedure. I'm just going to quickly do this one so you see how the crossover side works or looks like when it's done. Get it all unraveled first, starting with white, orange, orange, white, green. I like to look at the bottom here and make sure they're not tangled up, so they're nice and clean and easy to get into the connector later on. Brown, white, and the brown. Again, I just like to work it this direction, so I like to sometimes squeeze it and twist it so I make it all flat. Do that. So go ahead and cut this. So make sure you hold it down carefully. So this is gonna slowly feed into here. Feed this wire in here on a crimper. Put it on a crimper and crimp it down. So there you go. If I put this end to end, you'll see that the top one starts with the white, green, green, and the bottom one starts with the white, orange, orange. So this makes it a crossover cable. Now a couple of things I want to point out. After you crimp it, you should do an inspection on it. Again, one is that the jacket, the insulator on the wire is seated in, because this adds strain relief, okay, to the cable when it's plugged in. I've seen it where some people make a cable where the jacket is actually completely out. So the whole tension of this cable is held in by the pins here. And the weight of the cable will actually cause some of these wires to come loose. Okay. The other thing I've seen is, depending on what type of crimper you've used, I've had this guy that actually made a lot of RJ45 connectors where I had to go back and cut off the ends and redo it because the crimper he actually used a very expensive one. I think, like this one here, I think I picked up for like 16 bucks back in the day at Radio Shack. He picked up one that was like, I don't know, $80, $90. It was a ratcheting one. I mean, it looks really fancy and cool. The die that was on the crimper was, I don't know if there's something wrong with the die or whatever it is, but basically if you look at the end of it after he crimped it, I mean he crimped that thing tight. You would actually see the pins. The first and last pin is crimped down, and then it starts bowing up top near the middle. So like the pin like 3, 4, 5, they were actually not even crimped down onto the wire, making no contact. And he thought it was good. I mean, he made hundreds of them, plugged into the equipment. Next thing we know is that they had no connectivity, no link on the switch or the router. So we had to fix all that. So what I usually like to do is just look at the ends of it, make sure the pins are all flat. They're all crimped down. And you actually also see on the side where the middle tab is crimped down. Alright. I will do a second video. And this second video is actually a cable tester for Cat5. And you'll see there's a switch here. I won't get into that. I added that switch for another reason, which is not important. But anyways, I'll show you another video how to use these testers. They're very inexpensive. You can get these a lot of places for like 15, 20 bucks. But they're handy. So if you have any comments, leave me a comment below. And if you like the video, please subscribe. Alright? Thank you for watching.